Okay, welcome back. I think that video got cut off a little bit at the end, but you didn't really miss much. Essentially what I was saying is that we should move on now and start looking at what exactly the different parts of the EKG mean for us so that we can get an idea of what each piece means and what's happening in the heart when we look at it. So this should be, again, a review for most of you. I'm assuming you know this is the P wave, and this is the Q, R, S. This is T, and sometimes you'll get a little bump called a U wave after the T. So, what do each of these stand for? And what's happening? We also have a bunch of intervals and complexes. We have the PR interval, which is this. We have the QRS complex, which is about that. And we also have the QT interval. So that's kind of a lot of stuff going on. So let's try to break this down a little bit. So first, the P wave. The P wave is going to show us what's occurring during atrial depolarization. So the depolarization of both atria is going to occur right at that P. And it doesn't matter, I'm not concerned if you know the length of the P wave itself. Then we know that we have this traveling of the traveling and delay that occurs of the impulse down to the AV node and then through to the bundle of His, through the bundle branches, and then you have your Purkinje fibers and ventricular depolarization. So this PR interval is going to show us the time that this transmittal here is occurring. And if this delay at the AV node is lengthened, then you may see a much longer PR interval. So the PR interval is something that you should know. Typically, you're going to want the PR interval to be 0.12 to 0.20 seconds long. Any longer than 0.2, and you probably have some sort of heart block that's going on at that time. So the Q wave stands for this intraventricular depolarization. And you're not going to see it on every EKG. You notice I put an EKG here. You can't really see a Q wave. I drew one in here because I was going to use this one, but I thought it was a little small. But this strip does not have that. So just be aware you won't always see a Q wave. And sometimes you see a Q wave, and if it's deep, that's what's known as a pathological Q wave. And you can see these as a result of MIs. So from the Q wave, we have the QRS complex, and that is going to be the ventricular depolarization. And as we talked before, it can be upright or it can deflect downward depending on what lead you're looking at. The QRS complex, you may see some people listed as 0.04 or 0.08 to 0.12. Any larger than 0.12, and you're going to end up having a widened QRS that could be occurring for a number of reasons. Maybe a premature ventricular contraction is occurring. Maybe you've got some sort of VTAC going on, which really it's hard to even see what the rhythm is at that point. So this is something that you should be familiar with, is you want your QRS interval less than 0.12 seconds. Next we move on to this ST segment, and during the ST segment is essentially when ventricular contraction is occurring and the blood squeezes out. We move on to the T wave, and that is going to be the ventricular repolarization that occurs. And that, again, I'm not as worried about the T being, that you know the length of the T wave. But an interval you should know is the QT interval. And this, I'll draw it again here. It's the start of the Q to the end of the T. And this QT interval should be about 0.34 to 0.43. Now, a lot of times we'll use what's called the QTC, or the QT corrected, and that's corrected for heart rate, and that's essentially the QT over the square root of the R to R interval. And later on in another video, we'll talk a little more about why it's important to know what the QTC is. So hold your hat for that, folks. And then the U wave can be pathological, cannot be. You don't really measure, you don't expect to measure it and typically see what it is. You just sort of note that it's there. So these are all of our EKG waves and intervals. And again, I think knowing the PR, the QRS, PR interval, QRS complex length, and QT is important. Other things you may see that'll be interesting is if someone is having an acute, oops, I'm running off the page. For example, if someone is having a myocardial infarction or a heart attack, that's where you see things like you'll have a P wave, you may have a pathological Q wave, but you may see this ST segment that's elevated, and that's where we get STEMI from. ST segment elevated myocardial infarction, and we call those tombstones. You don't want to see that on an EKG. So just a little bit about what we want to know for our movement of the of the electrical conductance through the heart, and then how does that relate to what you're going to see on the EKG segment. So hopefully that makes sense, and in class we'll be able to review it. So this is just our sort of way to get used to kind of some of these terms. And so now that we have an idea about what all of the pieces of the EKG stand for, let's try to move on and figure out then how are we going to calculate heart rate, because that's important as well, in addition to the morphology that you're encountering. So there are several ways to calculate heart rate, and they essentially are determined by whether it's a regular or an irregular heart rate. So this is actually two strips we're looking at right here, which is a little confusing. But what they're showing is what's known as the 300, 150, 100 rule. And you're going to start at a beat that is, so first look at your strip and determine if it's regular. And let's see, we can pick, here's a strip that's regular. And we know it's regular. I have some calipers here, and I can open them up and go like this and see that the R to R interval is consistent. The R's are the same distance apart. So when I do that, then I know that this is a regular rhythm. And I can pick a beat that's essentially, this is on a line. So I would start counting 300, 150, 100, 75, and lo and behold, there's a beat, at 75. So this heart rate is somewhere around 75 beats per minute. Now this only works though if you have a regular rhythm. If you have something like bradycardia, after you get to 75, it's 60, 50, 43, 38. So you can see that we only see a piece of this strip, that this would need to be a regular strip, a regular rhythm. And we typically are going to use the 6-second strip to calculate our heart rate. And remember that a 6-second strip is going to be 30 large boxes. So what's going to determine the method we use to calculate heart rate? It's going to be the regularity of the rhythm. And I'll show you why in a minute. A normal heart rate, we talked about this, about 50 to 100 at this point. And then we have a question, determine the heart rate of some of the strips we have provided for you. And which one can use the 300, 150, 100 method? So let's look and see. So here, if you look at this strip, you see these are 3-second hatch markings. And if you counted all these boxes, you would get 30 large boxes. So let's see, does this look regular? Well, we can figure out right here. Let's see. Looks pretty regular to me. So we can use the 300, 150, 100 method. So we can try to find, this is exactly on the line. So 300, 150, 100, 75. It looks as though this spike, this R, is a little bit higher than the 75. So I would guess this is a heart rate of about 80 beats per minute. Now another way we can do this is by counting. 1, 2, 3, 4, 5, 6, 7, and this 8 is kind of right on here. So if this were a machine, it would probably count the heart rate between 75 and 80. Sometimes you'll also see the spaces counted. I believe the undergraduate textbook says to count the spaces. But you, in the end, get a heart rate that's pretty close. So we are saying our heart rate is 80. Now let's come down here. When we look at the, this looks like flutter here, atrial flutter, which you'll learn about. It's a sawtooth pattern. And sometimes the markings on EKGs are a little odd. This has a marking every 3 seconds. This has a marking every 6 seconds. So again, if you're not sure, you can always count your blocks. Make sure you have 15 large blocks. Now, if we're doing just the counting how many beats, we're on the line here, so we can choose or, count this or not count this, maybe count and add 5 at the end and not count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our heart rate is around 90 to 95, you could say, for this strip. Now, why aren't we using the 300, 150, 100 method? Can we use that? Well, let's see. Here are 2 R to R intervals. Let's see the next one. Oops, that doesn't work. Oh, whoa. Uh-oh. As you can see, this is an irregular rate, ventricular rate. Oh, look at that. Whoa. Because of the irregularity, what would happen if I picked a random beat? So let's say this is the beat I'm picking. So 300, 150, 100, 75. So yeah, it looks like it's around 85. Why are you complaining? We already counted and got, what do we have? 90? 2, 3, 4, 5, 6, 7, 8. We said our heart rate was 90. So what's the big deal? Well, what happens if we pick something like these 2 beats? 300, 150, almost 100, maybe a little bit more. That's a lot higher, and that's different than 90. So you can see, what about this? What if we go from here to here? 300, 150. Whoa, the heart rate here is 150. So you can see, because this is irregular, we were unable to use the 300, 150, 100 method. and instead we will resort to counting, which works just fine. This concludes the second video in the series for our journey toward how to interpret a 12-lead EKG. I hope this made sense. Let me know if you have any questions, and thank you for watching. Bye.